This is the lesson that we will need to do before the end of the term, because we're going to do some graphing again at the end of the term. And you'll need to review your graphing skills, because at the end of this term we're going to be doing graphing linear inequalities. So we need to remember how to graph equations to be able to do this and deal with equations. So we'll begin with our review. And to begin, we are going to start with some vocabulary. So first of all, we're going to talk about what is an ordered pair. And an ordered pair is two numbers. Keep in mind that it's two because it's a pair, that are associated with a point on a graph. And the first number is going to give us the horizontal location of the point. And then the second number is going to give us the vertical location. And when we have an ordered pair, then we're going to be talking about two coordinates, the first and the second coordinate. And the first is usually referred to as the x coordinate, although it can be other letters besides x. And then we also have a y coordinate, although it could be other letters besides a y. But generally when we're talking about graphing, it's usually x and y, and if we need to, we'll even convert those variables to x and y. And the key thing to remember here is what is the x-axis, what is the y-axis, and what is the origin. So the x-axis is the horizontal number line. And then the y-axis is a vertical number line. And the key thing to remember is the location of the origin. And the origin is where the x and the y-axis cross. So it's the point of intersection of the two axes. We also talk about the quadrants, and that's the four regions created by the intersection of the two axes. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4, and they're usually denoted by Roman numerals. And notice that we number them in a what's called a counterclockwise direction. And they're called quadrants because there are four of them. Quad comes from quattro, or quad means four of something. So now we're going to talk about graphing an ordered pair. And in order to graph the point that corresponds to a particular ordered pair, A, comma, B, you start, and this is very important, you start at the origin. You always start at the origin. And then what you're going to do is you're going to move A units to the left or to the right. And it's going to be right if A is positive and left if A is negative. And we're going to be moving right or left of the origin as step 1. Then for our second step, we're going to move B units either up or down. We're going to go up if B is positive and down if B is negative. And it's very important that you remember you're always going to go right or left first, then up or down when you're plotting your points, and you'll always start at the origin. So in this particular situation here, we're going to talk about plotting 2 points and why it's important to notice that the order of the two numbers is different. So the first point that we're going to plot is going to be the point -4, 2. And in starting to plot the point -4, 2, we're going to begin at the origin, and we're going to move left 4, 1, 2, 3, 4, because the 4 is negative. And then the 2 is positive, and it tells us up or down, so we're going to move up 1, 2. And that's going to give us the point -4, 2. Now, alternatively, we can look at how would you plot the point to -4. And that point is going to have the same coordinates but not in the same order, therefore it is a different ordered pair. So we're going to begin once again at the origin. And we're going to go right 2 because the 2 is positive, and remember we're always going right or left before we go up or down. So we're going to go right 2, and then we're going to go down 4. And that's how we locate the point to -4. And notice that those 2 points are in totally different locations. Even though they have the same 2 numbers, the same 2 coordinates, their x coordinates and their y coordinates are in different orders, and that gives us 2 different ordered pairs. So this one is 2, -4. And the other one was -4, 2. So be sure when you plot your points that you do the order correctly. And remember that each ordered pair corresponds to exactly 1 point in the plane, and that each point in the plane corresponds to exactly 1 ordered pair. 1 ordered pair, 1 place, 1 single place. So we're going to practice by plotting some points here. So the first point that we're going to plot will be 4, 2. And that means we're going to go to the origin. And we're going to go right 4. And then we're going to go up 2. And that gives us the location of the point 4, 2. Next, we're going to plot the point -3, -2. So we're going to go -1, 2, 3, and down 2, which leads us to this point. Now remember, only the points are what you're plotting. We are not plotting those parts. Those are actually how we get to those points, but they're not included in the plotting of the point itself. I'm just trying to make sure you understand where we're going. So then our next point that we're going to plot is going to be 2, -3. So that means we're going to go right 1, 2, and down 1, 2, 3. And we have the point 2, -3. Then we have two other points, and these points are kind of special. The first of them is 0, 4. 0, 4 means that we go to the origin and we don't go right or left at all. We simply go up 1, 2, 3, 4. So here's the point 0, 4. Notice that that's where the point crosses the y-axis. So that point is on the y-axis. Similarly, the point 5, 0 says that we go to the right 1, 2, 3, 4, 5. And that point is on the x-axis. And that's because the 0 is used for one of the coordinates, but if the 0 is in the y position, it's on the x-axis. If the 0 is in the x position, it's on the y-axis. Now we'll talk a little bit about whether or not an ordered pair is a solution of an equation in two variables. And an ordered pair is a solution of the equation in two variables if you replace the variables with the values of the ordered pair, and it results in a true statement. And if you know one coordinate of the ordered pair that is a solution for an equation, then you can find the other coordinate by using something called substitution, which means plug and chug, plug in the value you have, and you solve the resulting equation. So we'll practice with that now. So here we have the ordered pair, 3, something. We don't know the second coordinate. But the equation is 2x plus 5y equals -4. That means we're going to let x be 3 in the equation that we have. So that's 2 times 3. Plus, we don't need parentheses, 5y equals -4. And then because we know 2 times 3 is 6 plus 5y equals -4, we'll subtract 6 from both sides, and 5y equals -10. Y will equal -10 divided by 5, which is -2. So the completed ordered pair is 3, -2. And we know that 3, -2 is a solution to the equation 2x plus 5y equals -4. Here we're going to do the same thing again, only this time we're looking for the x coordinate, and we have that y is equal to -7. So if y is equal to -7, we have 3x minus -7 is equal to -5. And that means that 3x plus 7, because when you subtract a negative, that's addition, equals -5. And we'll subtract 7 from both sides, which gives us 3x equals -12, and then x equals -12 over 3, which is, of course, -4. So our ordered pair is -4, -7. And -4, -7 is a solution to 3x minus y equals -5. Now the reason that we would want to do this is because we're going to be able to plot points that are solutions to an equation and then draw a graph of that equation. And in order to do that, we're going to complete a table for that equation. So on the first one, we have that x is equal to -4, and we know that y equals 5x. So if we're going to let x be -4, y equals 5 times -4, and that makes y equal to -20, which we see here. And then similarly, going back again to y equals 5x, we look and see that in our second entry in the table we have y equals 10. So substituting 10 for y is equal to 5x. That tells us then that x is equal to 10 over 5, which is 2. And that gives us the second entry in the table. And again, y equals so here we have y equals 5x still, and in the table we are given, so here we have y equals 5x still, that, and in the table x we are given to 3. That, so x is equal to, say, 3. Y is equal to, so 5, we will say 3. Y, which is equal to 15. 5. So for x equals 3, y is equal to 15, and that's 15. Our third point. So for x equals 3, y is equal to 15, and that's our third point. So now we have a definition. Definition of a linear equation. In definitions of a linear equation are in this case x and y, and our two variables are in this case x and y. And that linear equation in something called standard form, and that linear equation in something called standard form is equal to c times x, and c is a real number. Y is equal to c. A and b are also c is real numbers. So it could be like 2x A and B are also both real numbers. The only hitch here is that both A and B equals 5 cannot be 0. The only hitch here is that both A and B, but not both of them, cannot be 0. And the remaining thing to remember is that it's a linear equation. And the remaining thing to remember is that it's a linear equation. Therefore, it's going to graph as a straight line.